Hi, this is Professor Tiffany Martin with Medical Microbiology. We are in Chapter 1 and we are working our way through. Okay, so Louis Pasteur is living at this period of time. And let me just ask you a question. Has anybody heard of Louis Pasteur? Of course you have, because Pasteur is short for pasteurization. This is a process he developed that we use today, still today, to preserve our milk and our juice and other things are pasteurized. I bet you have not heard of Spallanzani or Needham or Reddy. The reason we have heard of Pasteur is because his experiments at this time period held up, and it still holds up today. So Pasteur is a scientist living in this time period. He knew about Reddy and his experiments. He knew about Spallanzani. He heard about the critics. Pasteur did not believe spontaneous generation was possible. He said that living things have to come from other living things. So he set about designing a good experiment that critics could not question from that. All right, so let's see what Louis Pasteur did. Louis Pasteur did the same thing as Spallanzani. He took a glass container, he added plant matter and materials, and he boiled it. He boiled it a very long time. But what he did is he wanted to be able to make sure that air could come in and out of these containers. So he created this new shape to these containers, to these flasks, and this is now known as the Swan Net Flask. You can see how it bends here. Now this does two things. You can boil it in the glass container because steam can escape. The other thing is we know that if steam can escape, air can move in. So air can freely move in and out of this. So for the critics saying that air is necessary for spontaneous generation and you need some sort of life force in the air, this allows the air to move in and out. All right, so Pasteur, he boiled his plant material, he kept it in the flask, allowed it to cool, and then he allowed it to sit. And he watched it, made observations 1 day, 2 days, 3 days. The entire time, there is no growth. There is no cloudiness. There are no microorganisms. He repeated this experiment over and over again. He allowed these to sit up until 18 months. He actually had like this under the staircase cabinet, and he kept all of these things in this area under the stairs, and they would sit on the shelf for months. He would come back to them, make observations, and the entire time this liquid did not get cloudy, did not decay, did not smell. It remained without microorganisms contamination. What he did notice was that dust began to gather. So as air is coming in and out, dust would also come, collect here, and stay there. So one day he got the idea to see what happens with this dust and what would happen if this dust came in contact with the liquid. So he tipped his flask, allowed the liquid to come in contact with this dust that was collected here, set it back upright, allowed it to sit. After 1 day, 2 days, he got a cloudy liquid. Microorganisms appeared. His conclusions: spontaneous generation does not exist. Microorganisms come from other microorganisms from this. Air can come in and out as long as the dust and what we know now, the microorganisms within the dust, do not come in contact with the liquid stays sterile. Now this was pretty exciting. This was a solid, well thought out experiment. It answered all the critics' questions about this, and from this moment on, people became convinced spontaneous generation does not exist. And in fact, Louis Pasteur made a famous quote that he says, "Never will spontaneous generation recover from the mortal blow of this simple experiment." I think this is kind of funny. It just kind of shows that what happens when you design a good experiment, when you answer all the questions and design that experiment, then it stands, then your data stands. And so this is another reason why Pasteur's experiment still, this particular one, remains valid today. We have not gotten any new data that has contradicted what he did. And that, again, was the design of a good experiment.